Welcome to Teja Statistics. Today we are learning about ANOVA, which is useful for business statistics and also the BSc people. ANOVA, which stands for Analysis of Variance, is a statistical test used to analyze the difference between the means of more than two groups. So here you can see the analysis of variance is used to compare more than two means at a time. ANOVA compares the variation between group means to the variation with the groups. If the variation between the group mean is significantly larger than the variation within groups, so it suggests a significant difference between the means of groups. So ANOVA calculates an F statistic by comparing between groups of variability within group variability. If the F statistics exceeds a critical value, it indicates a significant difference between groups means. So ANOVA is used to compare the treatments, analyze factors impact on a variable, or compare means across multiple groups. Types of ANOVA includes, that is, there are only two types of ANOVA is there. One is ANOVA one-way classification and ANOVA two-way classification also. So here for comparing means of groups, two-way classification for examining effects of two different variables on dependent variable. Let's see the ANOVA factors like this. If you consider the medicines of 5 mg and 10 mg and 20 mg, do they differ significantly or having the same effect on the given? So mode of payment factor here we are trying to test. So GPay, PhonePe, and also IMPS, NEFT, like that. So do they differ or do they give the same conclusion we want to test? Okay. So types of ANOVA. ANOVA one-way classification. ANOVA one-way classification in the sense one factor with at least two levels. These levels are independent. So example, doctor want to test a new medication to a particular disease. Okay, he used to give the pills to the patients. They are about 10 mg and 20 mg and 30 mg, and they given the data like this. Okay, so here repeated measures of ANOVA, and one factor with at least two levels are depends. Next, consider another example. So how it is running as considered as a factor. So day 1 and day 2 and day 3. So day 1, if you are running 8 kilometers, day 2 5 kilometers, day 3 6 kilometers, these are the levels. Okay, next, factorial ANOVA, two or more factors. If you consider two or more factors for each of which at least two levels. So here you can see running and here the day 1, day 2, day 3, they are given more values, you can see here. Okay, testing of hypothesis. How you are going to test the hypothesis for ANOVA. Here all the means are equal. Mu1 is equals to mu2 equals to mu3 and so on, mu k. Alternative hypothesis, at least one of the mean is not equal. F test statistic you can see. So this column wise is called within the variance. The variance for between you can see as a over of row wise. So mu naught is equals to x1 bar, x2 bar, x3 bar. Here three levels they are considered. At least now by seeing this, you do the average for x1 bar and you do the average for x2 bar, and for x3 it is denoted by x3 bar. So H0 H1 after preparing the ANOVA one-way classification. One factor with at least two levels are independent. Okay. So same doctor's example. Okay, MG's example you can consider. So here the alpha is level of significance, at what percentage you want to test, and confidence intervals can be the 95%. Calculate the degrees of freedom. So the total given values are capital N equals to 23. How many levels? They are the three levels. Here G equals to 3 and N equals to, how many number of rows are there? N equals to 7. So if you consider like this, 1 2 3 4 5 6 7 rows and 3 columns, total 21. So here you can do the degrees of freedoms like this: 21 minus 1 and G minus 1 and capital N minus 1, like that. So degrees of freedom you can see 21 minus 1 is 20, E capital N 21 minus 3 as for the within the error, so that is considered as 3, that will be the 8. 2 comma 18 F test table you have to see. So by the decision you can see that the rejected area and the accepted area. If the F test is greater than 3.5546, then reject H0, otherwise you have to accept the H0. Calculate the F test statistical tables like this: sum of squares and degrees of freedom, mean sum of squares, and F calculated value. Here it is more than that, so hence 15 mg, 30 mg, 45 mg, if you consider the averages they are doing and the total and the square. Here are some sum of squares within total. Okay, you can see the formulas, you can easily identify that. So here 86.56 is greater than 3.196 or 156, you can say. So 3. It is greater than, hence we have to reject the null hypothesis. In this way you can easily understood about the ANOVA one-way classification for the given data. Okay, this class is very useful for the business statistics and also the research and methodology for paper 6, that is semester 6 persons also become semester 6. Okay, very simple and easiest calculations you can see. What they did here is the row totals and their squares. Okay, and squaring all the values. Sigma y square means 9 square plus 8 square plus 7 square and so on, like that. Okay, finally they calculated the F test statistic and they represented all these values in over here. First, what they did, they calculated the sum of squares and they divided by its degrees of freedom is follows the chi-square variates, that is mean sum of squares. So 98.67 divided by 2, we got 49.34, and 10.29 divided by this degrees of freedom, that is 18, you got 0.54. If you do the F calculated this 49.34 divided by 0.54, you will get the 86.56. So this is how you got the F calculated. Thank you for understanding all these concepts. These are all very very important calculations for both BSc and BCom semester 6 research and methodology paper. Thank you.